Hey everybody, this is Ben. Welcome back to another Leetcode video. Today we're going to be looking at problem 1343 titled Number of Subarrays of Size K and Average Greater Than or Equal to Threshold. So we'll read through the prompt, we'll walk through some pseudocode and an example, and then we'll code up a solution together. So given an array of integers AR and two integers K and threshold, return the number of subarrays of size K and average greater than equal to threshold. So notice the word subarrays in this context is going to mean continuous or contiguous, I guess, in some cases. So we're only looking at things in order of size K. I can't just pick any K elements. They have to be in order. So for this first example, I'd have to pick 3 elements in order as my subarray of question. So that's important to the problem. Keep that in mind. So let's go ahead and talk through the problem, talk through some pseudocode here. So we simply need to find all subarrays of size K, and at each subarray we can gather the average of the sum of the elements to see if this value is greater or equal to threshold. We can use the sliding window approach. So just getting into the pseudocode, initialize a sum variable and a result variable. And in my approach, I'm going to use 2 for loops because I think that it's a little bit cleaner that way. You can do it in 1 for loop with an if statement, but I'll leave that up to you. So first, we initialize our sum variable and result variable. We'll use a for loop to find our first subarray only, testing if its average is greater or equal to the threshold, incrementing our result variable if so. Then we have a second for loop with I initialized as K, to find our additional subarrays. So this for loop is unique in that in each iteration we can simply add ARI, which is our current element, and subtract ARI minus K, which is our oldest element. So that will keep our subarray at size K, and it will use that sliding window approach. So we're taking off the oldest, adding the newest, keeping length K. Then we'll test if the average meets our criteria. If so, we'll increment our result variable and we'll end our for loop. And then we'll return our result. So let's look at an example here. This was given in the prompt for this problem. So here is our array. K is size 3, so our subarrays have to be size 3. Our threshold is 4. So first we will create our sum and result variables, our integer variables. In our first for loop, we'll just have it for I less than K because we just want to find our first subarray. So we're just going to sum up those elements and the for loop, and then we'll have an if statement that's going to test is sum divided by K, which is 6 divided by 3, greater or equal than 4, and if so, we'll increment our result variable. In this case, it's not, so we do nothing. Then getting to our second for loop, we'll walk through each iteration of this. So now I equals K. Because here we went up to I equals 2, so we want I to start I equals 3, which is K. So when I equals 3, what we're going to do is we'll add ARI, which is right here, and we'll subtract ARI minus K, which is right here. We'll do that every iteration. We'll use an if statement here to test if our prompt is true, that our sum divided by K, which is the average of that subarray, is greater or equal to our threshold. So in this case, 6 divided by 3 is not. It doesn't catch, so we move to the next iteration. When I equals 4, sum equals sum plus 5 minus 2. 9 divided by 3, again, doesn't catch. I equals 5, sum equals sum plus ARI, minus ARI minus K. In this case, 12 divided by 3 is greater or equal to 4. So we'll increment our result variable by 1. Now result equals 1. Going down to I equals 6, same thing. We add our current element, and we subtract our oldest element. The average is going to meet our threshold, so we increment again. When I equals 7, same case, add the oldest element, add the current element, subtract the oldest element. Our average meets our threshold, so we increment again, we end our for loop. So what we're doing in the sliding window approach is we're making sure we maintain a subarray of length k. We iterate through our for loop, we add a new element, and we subtract the oldest element, and that's going to keep the length at k. So keep that in mind as we code up a solution here. So first we'll create our sum variable. We'll create our counter variable, or result, I like to just call it c. Our first for loop will just have I less than k. And a little typo there. Now what we'll do here is we're just getting the sum of this first array, the first 3 elements in our first example. And what we'll say once it breaks is sum divided by k greater or equal to threshold. If so, we'll increment that result variable. Now we have a second for loop, and we'll start it at I equals k. I is less than ar.length, I plus plus. We'll say sum plus equals ARI minus ARI minus k. Again, adding our current variable to our sum, subtracting our oldest variable. This will maintain a length of 3 in that first example. And this is our sliding window approach. It's kind of a running sum because it's faster than recalculating the average every time. Instead, we can just add one element, subtract one element, and we move on. Now we'll test our condition here for threshold and increment if so. Then we simply return our C value. So as you can see, that meets our first test case. Let's go ahead and run the second one. And that works as well. So my last submission with this was able to get this 4 millisecond submission. Whenever I submit it while recording, it tends to run a lot slower, unfortunately, but this will pass and it should give you a time and memory space around this. So in this approach, with the additional for loop and if statement, we are using more memory, but it gives you a little faster solution, so I like it this way personally. You could do it in one for loop, so maybe think about on your own how you could do that. So thank you very much for watching. I hope you learned something in this video.